Good afternoon, everyone. Thank you very much for joining us today here. My name is Roberto Palacin from Newcastle University, where I'm a reader in Transport Futures and also contributor to this event. And this event is organized through the EPSRC network, H2 network for hydrogen-fueled transportation, which is part of a series looking at different aspects of hydrogen research in the transportation sector. And today we are looking at applications in the sector of railways. So we will be welcoming three speakers today on the subject of hydrogen and rail, of course. And they will give us some feedback from different aspects and different stakeholders in the applications of hydrogen, from Network Rail to Siemens, and of course, and some startups looking at transitional and very innovative technologies to bridge the gap between current propulsion systems and future key systems. We have asked a speaker to present for around 20 minutes. So our next speaker is Paul Baines from Siemens Mobility. He's the Business Development Director. There is Paul. And he's going to give us a very interesting presentation on some of the collaborations that Siemens is taking with Deutsche Bahn in Germany. Paul, whenever you're ready.
First off, a slight apology. I'm not where I was meant to be. A slight logistical nightmare this morning. Basically, my taxi didn't turn up and I couldn't get the train home, so I was meant to be in the Home Office. So I'm in the jury inn at Hinckley. As Roberto said, I'm the Sales Director at Siemens Mobility Rolling Stock for the region of the UK and Ireland. And what I'm going to tell you about really is a bit about what we've been thinking and what we've been doing. I'll try and move it quite briefly. There's certainly an overlap with a lot of the things that Stephen's just been through. It speaks for itself. You know, why is the case for hydrogen? I think we've talked enough about this, but I thought that picture sums it up quite well as a sort of starting point. And just to set out, you know, one of the constant debates that I get drawn into with hydrogen is why not electrify? And I think we all agree, you know, if you can electrify and it's economically viable, do it, because I've got a slide in a minute that's going to show it's the most efficient use of the energy, it's the cleanest, it's the best. But sometimes, you know, for constraints of physicality, timing, other reasons, you know, it's just not going to be possible. And that's why around 5 years ago, we started developing R&D, set away 2 R&D projects within Siemens to develop alternative propulsion systems in hydrogen and battery. I'm not going to talk too much about battery today because this is a hydrogen session, but I think we all understand why this is needed. When we look at the global market, so Siemens is a global business. Like I say, I'm the head of sales for this region. But we, in terms of a lot of R&D investment, that's controlled by sort of global trends. This is a slide that one of my colleagues who's heading up the hydrogen project uses a presentation that he gives to management and other people. And I'm quite pleased to see that the UK actually features in the sort of global thinking, because it's, you know, we all understand what net zero 2050 is. We all understand that there's a target being set to remove diesel trains from the network by 2040. But it's these global sort of trends that do dictate where that R&D has been. And I'll talk through some of the challenges in a minute. So I just wanted to give that sort of global perspective. And then the detail that I'm going to show you today is our Mirio platform, which is a platform. It's an articulated train concept for the mainline European market. What we will be looking to do is bring the same technology to the UK for our 23-metre conventional train, you know, 2 bogies per car train, that's going to be called the Zero Verve. So the train that you see on the screen today is not the train that we'll be bringing to the UK. It looks very similar. But like I say, once the investment in the R&D has been developed, then its application in markets globally is what we're working on at the moment. Case for alternative drives. I'm summarising the same point that Stephen was making. You know, I think the graph there that shows sort of short distance, long distance kind of speaks for itself. Battery trains are range limited. I mean, indeed, hydrogen trains are range limited in a different context in terms of the mileage that we can get. But it's the right solution for the right project at the right time is the answer. And I think Stephen talked through the TD&S and the thinking that they have in terms of the end state and where hydrogen could be used. But it's also that interim phase. You know, if we really get going with the electrification, I think it's going to take at least 20 years to get your 11,000 or 12,000 track kilometres done, Stephen. So you know, it's what do we do in the interim? We've got a diesel fleet in the UK. I've lost track a little bit with trains coming out of service due to the pandemic, but it's around 3,700 vehicles. Around 40% of that is, over 23 years old. Some of them are 40 years old plus. So the sort of demand for self-power, I think is quite clear. The work I do as well, I'm quite sort of active in debates in this area on social media, on LinkedIn and Twitter, and actually I get quite a lot of responses, particularly from pro-electrification people. And actually, when I get that, I actually take some messaging, because I think it's about different technologies, and I thought this was quite a powerful slide, because the case for electrification is very clear there. You can see it. It's the most efficient use and most efficient use to get power to your wheels. But if you look at hydrogen compared to diesel, and it depends where your hydrogen comes from, of course. There's a debate on, grey, blue, green. That's those sorts of things. I've got my own views. But actually, the power at the wheel efficiency of hydrogen is similar to diesel. So in terms of what you put in and what you get out, now the energy density is different. So you've got to be very careful with your messaging. But I include that because I think that's quite a powerful sort of demonstration of how hydrogen can really work, and it's where your fuel comes from that is the ultimate question. So what when we kicked off this sort of R&D project in 2016, what are the sort of challenges that we have? Our competition were doing the same things at the same time. We heard about the island earlier. Alstom have certainly been quick to move into this space. But what are the challenges that we have with hydrogen? Well, generally there isn't a fuel network for it in the UK currently. If you're going to get it, you've got to get it from where it's produced to get it to where you need it. So that's got to evolve. And we talked about, I think Stephen mentioned the sort of hydrogen economy. It's got to evolve with mobility to make it competitive. It is quite complex technology. There's a lot of considerations. The factors like, the gradient and the sort of any incline or any sort of descending routes, does really impact the sort of power output you can get, the ranges you can get, the speeds you can get with hydrogen. And temperature, and also the green hydrogen. It's the object. You have a train that's clean at the point of use, but you're sort of shipping hydrogen around the country in sort of diesel trailers. That just doesn't feel right. So we've got to get there's got to be a level where price of through volume would agree that's not quite there. But here's a bit about the sort of R&D that we kicked off in 2015. I won't bore you too much with this, but I was going to say in the Siemens way, but this is how all OEMs work. So we set off with a challenge. We defined what we wanted to do. We designed, built, and tested the components. We prototyped them, and then they're now ready to be incorporated into the rolling stock, which I'll come to in a moment. We partnered with Ballard in the development of a fuel cell design specifically for railway traction, which is, I think it's a 200 kilowatt output. I think most proprietary systems that you can get are 100 kilowatt. I think certainly the ones that have been used in the past are kilowatt. And what that's designed to do is enable sort of full EMU performance. But when we talk about acceleration, the fuel cell, we want to use the fuel cell to make sure that when Stephen mentioned all the trains electronic, it's where the electricity comes from. Well, you shouldn't really know whether you're on a hydrogen train or an EMU. It should feel the same. It performs the same. Speed is a limiter. The optimum sort of balance between maximum speed and range, we think around 100 miles per hour is the sort of maximum speed for hydrogen. You can go faster, but it's just the energy sort of consumption is exponential beyond that point. It feels like challenging me on some of these facts, and please feel free later. So we kicked this off in 2015, and I think the next slide just shows a sort of representation of what we're doing with the sort of components and their integration. So, put simply, you develop components that work and that fit. This is UIC gauge, mainland Europe, so there's more work to do for the UK. We've mentioned the narrow gauge, and that is a challenge actually in terms of the space. And we spent now probably the last 3 years integrating these components onto a sort of concept that can be built, and ultimately, I will get to the Deutsche Bahn project eventually. Ultimately, this has resulted in us entering an arrangement with Deutsche Bahn to deliver the full system that I'll come to in a minute. So, sounds straightforward, but I think a reflection of the innovation cycle that it takes. So, someone has an idea 5 years ago, and then only now are we in the process of delivering something in a contract. The rate of pace of change of technology is fast, but the innovation cycles to actually get it incorporated are quite long. If you think from, I'm going to show you a slide shortly that says that we'll have a train in service in 2024. That's 9 years since the project was incepted, and if you're predicting something in 9 years' time, who can tell what's going to be the right thing? So I think that's an important factor as well. And as you can see, it's about optimizing storage of fuel. Space is important. It's about a fuel cell we'll put in smaller space because, again, space on the train is important, and it's just getting that balance that you can come up with something that's in an operational context meaningful and can be used in duty cycles that fit with what operators of the trains require. But this is just an overview of the concept. The Mirio plus H, if you want to get a battery on your van, that's called Mirio plus B. We think we're probably going to call our UK product at zero verb will probably be plus H plus B and follow the same sort of track. But this just, I think that one of the past perceptions of hydrogen was it's a bit slow. It's a bit sort of like you're going to get more like a diesel performance, whereas we're very firmly coming to the market and saying, no, you get full EMU performance with these units when they're operating under fuel cells. So there's just some facts and figures about that there. I can make these slides available to people, by the way, if anyone's interested after this session. This is where we start getting into how and why the scheme that we've got into with Deutsche Bahn came around. So it's looking at the type of fleet and the type of operation that you want to run, and basically what your fueling strategy wants to be. And it's quite obvious. You go from a very small fleet, you're going to have a sort of perhaps a mobile fueling station. You can deal with that where through to a medium size, you need to get to a filling station with delivery. So you get your hydrogen to bigger operation. I mentioned, for example, the Thameslink fleet we delivered, for example, very large fleet. It's not, but if it was a project on that scale, then sort of self-production becomes the key. And that little sort of diagram there really is the full ecosystem. So it's generating renewable sources to generate clean electricity that's used to through electrolysis that then charges a fueling station, fuels your train in about. And that's really the ethos of the work we've done with Deutsche Bahn, and we're doing with Deutsche Bahn. I'll talk about a little bit more in a moment. Fueling. So one thing that we've worked through for the last 5 years really, is what are going to be the barriers to customers to buying these products. And actually, it's a big problem. Customers now, they run electric trains, they're on diesel trains, they run diesel, electric, bi-mode trains and hydrogen trains. They don't know how to fuel it, they don't know how to set the infrastructure up, they don't know, what it takes. So thinking about the fueling system and the speed at which it can happen and various other attributes, we've given that as much thought as we have the sort of componentry that's on the train. And again, you see a common feature there is the wind sort of turbines there to generate clean renewables. And what that comes to is this scheme that we've within Siemens we have a memorandum of understanding with our energy business. Quite conveniently produce electrolyzers and produce green electricity. But we're working with Deutsche Bahn now to prove this concept that you can clean from renewable sources. So that gives you portability. So when I think we talked about whether sort of power availability in the north of Scotland is sufficient for battery, well, this, I think it's quite windy up there. That if your railway's big enough, you can actually take it anywhere because you generate your own energy. So you use clean renewable energy to power an electrolyzer to produce hydrogen on site that then charges your fuel station. You then fuel the train, and as this shows the full cycle in the R&D scheme that we're doing with Deutsche Bahn, we're looking at what are the maintenance impacts of actually maintaining hydrogen trains. I think there are a lot of things that are obvious in terms of the componentry, but like we say, where's the fuel stored? How safe is it? How can that be done? How heavy is the equipment? How often does it need to come off? All of those sorts of things. So we're working with Deutsche Bahn to go through the full life cycle on this basis, and it's I'm not in touch with the complete financial arrangement. It's referred to as jointly funded. But actually what we're doing is both just learning, what we're going to do about this and learn on the job. Best way to learn is by doing it. And then once it's been delivered, then it's how it can be looked in the German market on a mass scale. And similarly, really like something we call hydrogen, very much like customers. You just tell us where you want to train on the morning and we'll deliver it for you in that location, ready to go out, and give us it, we'll do the same again and deliver it back to you the next morning, ready to go, provide the deliver. So we're thinking also about sort of contractual frameworks that could work for us, actually make their life easier. Is it about the Mirio again? In terms of the performance, it's a 220 seat, so there's no loss of
we're gonna have to leave it there. You finished that. Thank you very much, Paul, and thank you for